Hello, in this lecture we find out the area of trapezoid ABCD. In the drawing we have a circle that is inscribed by this trapezoid ABCD. In addition, we know that this is side AB of trapezoid ABCD, that is equal to x. This is side DC, that is equal to 7 over x. This is angle BAD, that is a right angle, and this is angle ADC, it is also a right angle. Again, our mission is to find out the area of this trapezoid ABCD. So, what is a trapezoid? Trapezoid is a quadrilateral with one pair of parallel sides. Repeat again. Trapezoid is a quadrilateral with one pair of parallel sides. This is trapezoid ABCD. You can see that trapezoid ABCD is a quadrilateral, and because of the fact that side DC is parallel to side AB, this quadrilateral is defined as a trapezoid. Repeat again, trapezoid is a quadrilateral with one pair of parallel sides. This quadrilateral ABCD, side DC is parallel to side AB, and therefore this quadrilateral ABCD is defined as a trapezoid. And what is the area of this trapezoid ABCD? The area of the trapezoid equals to the sum of its two bases times the height over 2. The two bases are defined as the parallel sides. Side DC is the base, and side AB is also the base of this trapezoid ABCD. DC equals to A and AB equals to B according to our definition, and therefore the sum of the two bases is A plus B times the height, that is edge, over 2. So the area of trapezoid ABCD equals to the sum of its two bases, that is A plus B, times the height edge over 2. And the height edge must create 90 degrees with the two bases. You can see here that edge creates 90 degrees with the base DC, this angle equals to 90 degrees, and the height edge also creates 90 degrees with the base AB, this angle equals to 90 degrees, and this angle also equals to 90 degrees, and therefore edge is the height to the two bases. So in conclusion, we should found out that the area of this trapezoid ABCD equals to A plus B times edge over 2. A and B are the two bases of this trapezoid, and the two bases are parallel to each other. The height edge must create 90 degrees with the two bases. Repeat again, the area of this trapezoid ABCD equals to A plus B times edge over 2. Okay, so in the first step, we will define the point of tendencies of this trapezoid with this circle with letters. We define the point of tendency of tangent AB with this circle, this point SE. We define the point of tendency of tangent AD with this circle, this point SF. We define the point of tendency of tangent BC with this circle, this point SG. And finally, we define the point of tendency of tangent DC with this circle, this point SH. So here we can implement rule 2. I'll repeat quickly on rule 2. According to rule 2, the lengths of two tangents from a common standpoint to a circle are equal. So in the drawing we have a circle, and we have, this is the connection point, point P. From this connection point P, we have two tangents to this circle. We have tangent PA and tangent PB. And according to this rule, all two they are equal to each other. That is to say, PA equals to PB. So I can actually implement rule 2 in our drawing. Why? Because in our drawing, if we focus on this connection point A, from this connection point A, we have two tangents to this circle. We have tangent AF and tangent AE. And according to rule 2, they are equal to each other. That is to say, AF equals to AE. So if we define the length of tangent AF as Y, then the length of this tangent AE must be also equal to Y because they are equal to each other, according to rule 2. Likewise, if we focus on this connection point B, from this connection point B, we have two tangents to this circle. We have tangent BG and tangent BE, and according to rule 2, they are equal to each other. That is to say, BG equals to BE. So if we define the length of tangent BG as Z, then the length of this tangent BE must be also equal to Z because they are equal to each other. Likewise, we'll focus on this connection point C. From this connection point C, we have two tangents to this circle. We have tangent CG and tangent CH. And according to rule 2, they are equal to each other. That is to say, CG equals to CH. So if we define the length of this tangent CG as M, then the length of this tangent CH must be also equal to M because they are equal to each other according to rule 2. And finally, we'll focus on this connection point D. From this connection point D, we have two tangents to this circle. We have tangent DH and tangent DF. Again, we have tangent DH and tangent DF. And according to rule 2, they are equal to each other. That is to say, DH equals to DF. So if we define the length of this tangent DF as T, then DH must be also equal to T because they are equal to each other according to rule 2. So if DF equals to T, then DH must be also equal to T according to rule 2. So what is the value of side AB plus side DC? Repeat again, what is the value of side AB plus side DC? AB plus the opposite side DC. AB, we just write down found out that according to rule 2, AB equals to Y plus Z. Again, AB equals to Y plus Z. Plus DC. DC, according to rule 2, DC equals to T plus M. So in total, we actually found out that AB plus DC equals to Y plus Z plus T plus M. Likewise, we relate side AD to the opposite side BC. So what is the value of AD plus BC? AD plus BC. Side AD, according to rule 2, side AD equals to Y plus T. As you can see here, from the drawing, it is very easy to see that side AD in total equals to Y plus T. Plus BC. What is the length of BC? From the drawing, it is very easy to see that BC in total equals to Z plus M. So actually found out that in total AD plus BC equals to Y plus T plus Z plus M. Here we can change the orders of this expression according to the algebraic identity that A plus B equals to B plus A. We can change the orders of this expression, Y plus T plus Z plus M, and instead of Y plus T plus Z plus M, we can write down that Y plus Z plus T plus M. So in conclusion, we found out that AD plus BC equals to Y plus Z plus T plus M, and AB plus DC also equals to Y plus Z plus T plus M. So those two expressions, they are both equal to this further expression, Y plus Z plus T plus M, and therefore they are equal to each other. That is to say, AB plus DC equals to AD plus BC. And again, according to equation 1, we actually found out that AB plus DC equals to AD plus BC. In the next step, we define the length of this line segment AD as A. AD equals to A according to our definition. Likewise, we define the length of this side BC as B. BC equals to B according to our definition. So, according to equation 1, this is equation 1, AB plus DC equals to AD plus BC. AB equals to X, according to what is given in the question, and DC, side DC equals to 7 over X, according to what is given as the question. So in total, AB plus DC equals to X plus 7 over X, and it is equals to, according to equation 1, it is equals to AD plus BC. AD equals to A according to our definition, plus BC. BC equals to B also according to our definition. So in conclusion, I actually found out that according to equation 1, X plus 7 over X equals to A plus B. Repeat again, according to equation 1, we actually found out that X plus 7 over X equals to A plus B. Okay. In the next step, we'll do a construction. That is to say, from point B, we will draw perpendicular on DC. Again, from point B, we will draw perpendicular on DC. So actually, this angle equals to 90 degrees in its size, and this angle also equals to 90 degrees in its size according to our construction. We define the touching point of the perpendicular from point B inside DC is point S. Actually, by doing this construction, we can do quadrilateral ABSD. This is quadrilateral ABSD. Inside this quadrilateral ABSD, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this fourth missing angle must be equal to 90 degrees in its size. Well, because 270 degrees plus 90 degrees, it is 360 degrees. That is the sum of the angles in any quadrilateral. So inside quadrilateral ABSD we have 4 right angles. And we know that any quadrilateral that has four right angles must be a rectangle, if not a square. So we relate to this quadrilateral ABSD that has 4 right angles as a rectangle. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle ABSD, side AB must be equal to the opposite side DS. But AB equals to X according to what is given us the question, therefore DS must be also equal to X. Likewise, according to the sum rule, in the same rectangle ABSD, side AD must be equal to the opposite side BS. So AD equals to BS. AD is A. Therefore BS must be also equal to A. So what is the length of this line segment? Line segment SC. The length of this line segment SC is equals to DC minus DS. Again, DC minus DS equals to SC. So I write it down. SC equals to DC minus DS. So SC equals to DC. DC is 7 over X according to what is given us the question. And we just write down found out that DS equals to X. So actually, in total we should find out that SC equals to 7 over X minus X. SC equals to 7 over X minus X. Actually, by doing this construction, we created here the right triangle BSC. So I copy this right green triangle BSC in a new page, and we will implement the Pythagoras theorem on this right triangle BSC. Here by PT is the abbreviation for Pythagoras theorem. Side BS equals to A. The hypotenuse BC equals to B according to our definition. And we just right now found out that side AC of the right green triangle BSC equals to 7 over X minus X. So actually, this is the right triangle BSC that I copied from the original drawing. In this right triangle BSC, according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. In this right triangle BSC, the hypotenuse is BC, therefore the square of the hypotenuse is BC square, and it must be equal to BS square plus SC square. So this is equation 2. BC, the hypotenuse BC equals to B, therefore BC square is B square, and it is equals to BS square. BS is A, therefore BS square is A square plus SC square. SC is 7 over X minus X, therefore SC square is 7 over X minus X square. So according to equation 2, we found out that b squared equals to a squared plus 7 over x minus x squared. Here we will use the algebraic identity that states that a minus b squared equals to a plus b squared minus 4 times a times b. We use this algebraic identity for the value of the expression 7 over x minus x squared. So according to equation 2, we found out actually that b squared equals to a squared, and here we have 7 over x minus x squared. According to this algebraic identity, a minus b squared equals to a plus b squared minus 4 times ab. We will get that 7 over x minus x squared if we just substitute 7 over x by a and x by b, we get that 7 over x minus x squared according to this algebraic identity will be equal to 7 over x plus x squared minus 4 times 7 over x times x. So according to equation 2, we actually found out that b squared equals to a squared plus, we have here 7 over x plus x. According to equation 1, we have already found out that 7 over x plus x equals to a plus b. So we can substitute 7 over x plus x by a plus b. If 7 over x plus x equals to a plus b, it means that 7 over x plus x squared will be equal to a plus b squared. And it is equal minus, we have here x in the numerator and x in the denominator, so x will get cancelled. After we cancelled x, we left only with minus 4 times 7, that is minus 28. So if we found out that according to equation 2, b squared equals to a squared plus a plus b squared minus 28. So here we'll open the brackets on this side of the equation 2, and we get that according to equation 2, b squared equals to a squared, and here we have a plus b squared. A plus b squared equals to a squared plus b squared plus 2 times a times b minus 28. So here we have b squared on both sides of the equation, so b squared will get cancelled. And after we cancel b squared, in this side of the equation we have with nothing, that is to say 0. In the other side of the equation we have a squared plus a squared is 2a squared plus 2ab minus 28. Again, according to equation 2, we actually found out that 0 equals to 2a squared plus 2 times ab minus 28. Here we will add 28 to this equation, equation 2, and finally we get that according to equation 2, zero plus 28 is 28, equals to, in the other side of the equation we have 2a squared plus 2ab. So actually in conclusion, according to equation 2, we actually found out that (28) equals to 2a squared plus 2ab. Here we will divide this equation 2 by 2. And finally we get that according to this equation 2, 28 over 2 is 14, equals to 2a squared over 2 is a squared, and 2ab over 2 is ab. So in conclusion, according to equation 2, we actually found out that a squared plus ab equals to 14. This is according to equation 2. While according to equation 1, we have already found out that x plus 7 over x equals to a plus b. Again, x plus 7 over x equals to a plus b according to equation 1. So we have here two equations. In the next step, we will find out the area of trapezoid ABCD. According to the formula that I presented to you in the beginning of the lecture, the area of this trapezoid ABCD equals to the sum of its two bases times the height over 2. The two bases are the two parallel sides. In triangle, in quadrilateral in trapezoid ABCD, which are the two parallel sides, we know that side AB is parallel to side DS in rectangle ABDS. According to the rule that the opposite sides of a rectangle are parallel to each other. Therefore, side AB is parallel to the opposite side DS in rectangle ABDS. But DS is part of the straight line DC and is parallel to AB. So if part of a straight line is parallel to another straight line, then the straight line DC itself must be also parallel to the other straight line AB. And therefore DC must be also parallel to AB. Therefore, the two parallel sides in trapezoid ABCD are AB and DC. And therefore, the sum of the two bases is the sum of the two parallel sides, that is to say AB plus DC. Times the height to the base. The height times the height, and the height must create 90 degrees with the two bases. Here it is very easy to see that side AD creates 90 degrees. This angle equals to 90 degrees. It creates 90 degrees with the base AB, and the same side AD also creates 90 degrees with the base DC. And therefore, the height to the base is AD divided by 2. So actually, in conclusion, we found out that the area of trapezoid ABCD equals to the sum of its two bases that are AB plus DC times the height, that is AD over 2. AB equals to x, according to what is given as the question, plus DC. DC equals to 7 over x, according to what is given as the question. Again, AB is x and DC is 7 over x times AD. AD equals to A according to our definition. Divided by 2. So in conclusion, we actually found out that the area of trapezoid ABCD equals to x plus 7 over x times A over 2. But according to equation 1, we have already found out that x plus 7 over x equals to A plus B. Therefore, we can substitute x plus 7 over x in this expression by A plus B. We will do it now. So x plus 7 over x is A plus B, and we have to multiply it by A over 2. In conclusion, we found out that the area of trapezoid ABCD equals to A plus B times A over 2. Here we open the brackets of this expression, and we get that A times A is A squared plus AB over 2. Again, the area of trapezoid ABCD equals to a squared plus ab over 2. But we already found out that a squared plus ab equals to 14. This is according to equation 2. Therefore, we can substitute a squared plus ab in this expression by 14. We'll do it now. So a squared plus ab is 14. So this expression in total equals to 14 over 2. And 14 over 2 is 7. In conclusion, we actually found out that the area of trapezoid A, B, C, D is equals to 7 square units. And that is the answer to the question. I repeat again. The area of this trapezoid ABCD is equals to 7 square units. So in the next step, I will summarize the lecture. In this lecture, we found out the area of this trapezoid ABCD. So, in the drawing, we have a circle that is described by this trapezoid ABCD. In addition, we know that side AB equals to x units in its length. This is side DC, that is equals to 7 over x units in its length. This is angle BAD, that is a right angle, and this is angle ADC, that is also equals to 90 degrees in its size. Again, our mission is to find out the area of this trapezoid ABCD. So, first of all, what is the definition of a trapezoid? A trapezoid is a quadrilateral with one pair of parallel sides. I repeat again, trapezoid is a quadrilateral with one pair of parallel sides. So here we have in the drawing, we have quadrilateral ABCD, and because of the fact that in this quadrilateral ABCD, it is given us the question it is given us that side DC, we know that side DC is parallel to side AB, so I write it down. Side DC, we know that side DC is parallel to the opposite side AB. For that reason, this quadrilateral ABCD is defined as trapezoid because it has one pair of parallel sides. So ABCD, quadrilateral ABCD is a trapezoid. What is the area of this trapezoid ABCD? Actually, the two parallel sides, that is to say DC and AB, they are defined as the bases of this trapezoid. We defined the base DC as A, and we defined the base AB as B. And the area of this trapezoid ABCD equals to the sum of its two bases, that is to say A plus B, times the height, that is h over 2. Again, the area of this trapezoid ABCD equals to the sum of its two bases, that are that is A plus B, times the height, that is h over 2. The height h must create 90 degrees with the two bases. And it is clear from the drawing that the height h creates 90 degrees with the base DC, this angle equals to 90 degrees, and the height h also creates 90 degrees with the base AB. Why? Because this angle equals to 90 degrees and this angle also equals to 90 degrees. So in conclusion, we have found out that the area a trapezoid is a quadrilateral with one pair of parallel sides. Here, side DC is parallel to side AB, and therefore this quadrilateral ABCD is defined as a trapezoid. And the area of this trapezoid ABCD equals to the sum of its two bases, that are A plus B, times the height, that is h over 2. The two bases must be parallel to each other. We know that side DC is parallel to side AB, and the height h must create 90 degrees with the two bases. Here, this angle equals to 90 degrees, and this two angles are both equal to 90 degrees. Repeat again, the area of this trapezoid ABCD equals to A plus B times h over 2. Okay. In the next step, we defined the point of tendencies of this trapezoid ABCD with this circle with letters. We defined the point of tendency of tangent AB with this circle, this point AC. We defined the point of tendency of tangent AD with this circle, this point SF. We defined the point of tendency of tangent DC with this circle, this point SG. The point of tendency of tangent BC with this circle is G. And finally, we define the point of tendency of tangent DC with this circle, this point as H. So here we can implement rule 2. According to rule 2, the lengths of two tangents from a common standpoint to a circle are equal. So here we have in the drawing a circle, and this is the common standpoint, point P. From this common standpoint, point P, we have two tangents to this circle. We have tangent PA and tangent PB, and according to this rule 2, they are equal to each other. That is to say, PA equals to PB. So whenever you draw from common standpoint to a circle two tangents to the circle, the lengths of two tangents must be equal to each other. In this case, PA equals to PB. We can definitely implement rule 2 in our drawing. Likewise, in our drawing, if we focus on this common standpoint, point A, from this common standpoint, point A, we have two tangents to this circle. We have tangent AE and tangent AF. And according to rule 2, they are equal to each other. That is to say, AE equals to AF. So if we define the length of this tangent AE as y, then the length of this tangent AF must be also equal to y, because they are equal to each other according to rule 2. Likewise, if we focus on this common standpoint, point B, from this common standpoint, point B, we have two tangents to this circle. We have tangent BE and tangent BG. And according to rule 2, they are equal to each other. That is to say, BE equals to BG. So if we define the length of this tangent BE as Z, then BG must be also equal to Z, because they are equal to each other according to rule 2. Likewise, if we focus on this common standpoint, point C, from this common standpoint, point C, we have two tangents to this circle. We have tangent CG and tangent CH. And according to rule 2, they are equal to each other. That is to say, CG equals to CH. So if we define the length of this tangent CG as M, then the length of tangent CH must be also equal to M, because they are equal to each other according to rule 2. And finally, if we focus on this common standpoint, point D, from this common standpoint, point D, we have two tangents to this circle, tangent DF and tangent DH. And according to rule 2, they are equal to each other. That is to say, DF equals to DH. So if we define the length of this tangent DF as T, then the length of this tangent DH must be also equal to T, because they are equal to each other according to rule 2. In the next step, we added side AB to the opposite side, side DC, in trapezoid ABCD. So what is the value of AB plus DC? Again, what is the value of AB plus DC? AB, according to rule 2, AB in total equals to Y plus Z. Plus DC. DC in total equals to T plus M. So in total, AB plus DC equals to Y plus Z plus T plus M. Likewise, we added side AD to the opposite side, side BC. So what is the value of AD plus BC? AD equals to Y plus T, and BC equals to Z plus M. So in total, AD plus BC equals to Y plus T plus Z plus M. So we have here the expression Y plus T plus Z plus M. And according to the algebraic identity that A plus B equals to B plus A, we can change the order of this expression. By changing the orders of this expression, we will not change the value of this expression. So instead of Y plus T plus Z plus M, we can write down Y plus Z plus T plus M. We just change the order of this expression, and therefore the value remains the same value. So this operation is allowable. So according, We just later found out that AD plus BC equals to y plus z plus t plus m, and we already found out that AB plus DC also equals to y plus z plus t plus m. So those two expressions, they are equal to the same third expression, and therefore they are equal to each other. Again, those two expressions, they are both equal to y plus z plus t plus m, and therefore they are equal to each other. That is to say, AB plus DC equals to AD plus BC. Again, AB plus DC equals to AD plus BC. We define the length for side AD as A, we define the length for this side BC as B. So, AB equals to X plus DC. DC equals to 7 over X, according to what is given as the question. Again, AB equals to X, DC equals to 7 over X. And it is equals to AD. AD equals to A plus BC. BC equals to B. Again, AD equals to A and BC equals to B. So according to question 1, we found out that X plus 7 over X equals to A plus B. In the next step, we did a construction. That is to say, from point B, we go perpendicular on DC. Again, from point B, we go perpendicular on DC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B in DC as point S. By doing this construction, we created here quadrilateral ABSD. Inside this quadrilateral ABSD, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore this fourth missing angle must be equal to 90 degrees in its size. Y equals 270 degrees plus 90 degrees. It is equal to 360 degrees. That is the sum of the angles in any quadrilateral. So this fourth missing angle must be equal to 90 degrees in its size. And therefore, inside the quadrilateral ABSD, we have 4 right angles. And we know that any quadrilateral that has 4 right angles must be this rectangle, if not a square. So we relate to this quadrilateral as a rectangle because it has 4 right angles. But we also know that, so quadrilateral ABSD is a rectangle, but we also know that the opposite sides of a rectangle are equal to each other. So in rectangle ABSD, side AB must be equal to the opposite side DS. Side AB must be equal to the opposite side DS. But AB equals to X, according to what is given as a question, therefore DS must be also equal to X. Likewise, according to the same rule, in the same rectangle, side AD must be equal to the opposite side BS. But AD equals to A, therefore BS must be also equal to A. What is the length of this line segment? Line segment SC. From the drawing, it is very easy to see that SC equals to DS. SC equals to DC minus DS. Again, SC equals to DC minus DS. Repeat again, SC equals to DC minus DS. DC is 7 over X according to what is given as the equation. DS, we just now found out that DS equals to X. DS equals to X. So in total, SC equals to 7 over X minus X. Again, SC equals to 7 over X minus X. In the next step, I copied the right green triangle BSC in a new page and we implemented the Pythagoras theorem on this right green triangle, triangle BSC. So this is the right green triangle, triangle BSC that I copied from the original domain. We found out that the hypotenuse BC equals to B, side BS equals to A, and we just right now found out that SC equals to 7 over X minus X. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this triangle BSC is BC, therefore the square of the hypotenuse is BC square, and it must be equal to BS square plus SC square. And again, according to equation 2, BC square equals to BS square plus SC square. BC is B, therefore BC square is B square, and it is equals to BS square. BS is A, therefore BS square is A square, plus SC square. SC is 7 over X minus X, therefore SC square is 7 over X minus X square. So we use the algebraic identity that states that A minus B square equals to A plus B square minus 4 times AB. we use this algebraic identity for the value of 7 over x minus x squared. According to this algebraic identity that states that a minus b squared equals to a plus b squared minus 4 times ab, we find out that if we substitute here in this expression 7 over x minus x squared, if we substitute 7 over x by a and x by b, we get that this expression, according to this algebraic identity, 7 over x minus x squared will be equal to 7 over x plus x squared minus 4 times 7 over x times x. Okay? And the other expressions, we just complete it here. We have here b squared is equal to a squared, and the expression 7 over x minus x squared, according to this algebraic identity, equals to 7 over x plus x squared minus 4 times 7 over x times x. So in conclusion, according to equation 2, we found out that b squared equals to a squared plus 7 over x plus x squared minus 4 times 7 over x times x. Here we have x in the numerator and x in the denominator, so x will get cancelled, and we have to only minus 4 times 7, that is minus 28. So in conclusion, according to equation 2, we found out that b squared equals to a squared plus a plus b squared minus 28. Here we open the brackets of this expression, a plus b squared, and we shall found out that according to this equation 2, b squared equals to a squared, and a plus b squared equals to a squared plus b squared plus 2 times ab minus 28. Here we have b squared on both sides of the equation, so b squared will get cancelled. After I've cancelled b squared, in this side of the equation we left with nothing, that is to say 0. And the other side of the equation we have a squared plus a squared, that is 2a squared, plus 2ab minus 28. So according to equation 2, we actually found out that 0 equals to 2a squared plus 2ab minus 28. Here we added 28 to this equation 2, and finally found out that according to equation 2, 28 equals to 2a squared plus 2 times ab. Here we divided this equation 2 by 2, and finally found out that 28 over 2 is 14, 2a squared over 2 is a squared, and 2ab over 2 is ab. So in conclusion, according to equation 2, we found out that 14 equals to a squared plus ab, or a squared plus ab equals to 14. This is according to equation 2, while according to equation 1, we have only found out that x plus 7 over x equals to a plus b. So we have here two equations. So what is the area of this trapezoid ABCD? According to the formula that I presented to you in the beginning of the lecture, the area of this trapezoid ABCD equals to the sum of the two bases times the height over 2. And the two bases are defined as the two parallel sides. What are the parallel sides in this trapezoid ABCD? First of all, we know that ABSD, this is a rectangle, and we know that the opposite sides of a rectangle are parallel to each other. So in rectangle ABSD, side AB is parallel to the opposite side DS. Again, side AB is parallel to the opposite side DS in rectangle ABSD. But DS is part of the straight line DC, and it's parallel to AB. So if part of the straight line is parallel to another straight line, then the straight line DC itself must be also parallel to AB. So I found out that DC is parallel to AB, and therefore the two parallel sides in trapezoid ABCD are AB and DC. Therefore the two bases are AB and DC. And the sum of the two bases is AB plus DC. Again, so the area of trapezoid ABCD equals to the sum of the two bases that are AB plus DC. Because of the fact that AB is parallel to DC, the two bases are AB and DC. And therefore, the sum of the two bases is AB plus DC times the height. The height must create 90 degrees with the two bases. And we can see here that side AD creates 90 degrees with the base AB. This angle equals 90 degrees. And also the same side AD creates 90 degrees with the base DC. And therefore the height is AD. Again, the height is AD over 2. In conclusion, we found out that The area of trapezoid ABCD equals to the sum of the two bases that are AB plus DC times the height that is AD over 2. AB equals to x according to what is given as the question, and DC equals to 7 over x according to what is given as the question. I repeat again, AB is x, DC is 7 over x, AD is A according to our definition, and AD is A. So in conclusion, we have found out that the area of trapezoid ABCD equals to x plus 7 over x times A over 2. But according to equation 1, x plus 7 over x equals to a plus b. Therefore, we can substitute x plus 7 over x in this expression by a plus b. We did it. So x plus 7 over x is a plus b. So in total, this expression will be equal to a plus b times a over 2. So the area of trapezoid ABCD equals to a plus b times a over 2. Here we open the brackets of this expression. And finally found out that a times a is a squared plus ab over 2. But ab plus a squared plus ab, according to this equation 2, a squared plus ab equals to 14. Therefore, we can substitute a squared plus ab by 14. According to equation 2, we did it. So a squared plus ab is 14. And therefore, this expression in total equals to 14 over 2. And 14 over 2 is 7. So finally found out that the area of this trapezoid ABCD equals to 7 square units. Okay, thank you very much.